Hey everybody, so I wanted to make a short video. On Rust, and as I'm just learning this language, and I wanted to make videos on my progress and then share it with people so other people could learn it too. And so I'm just kind of going through the Rust documentation section by section, and this is going to be on section 3.1 and 3.2. Mainly 3.1 though, on variables and mutability and data types. And so yeah, let's get into it. So basically, and if I don't say everything exactly correctly in these Rust videos, feel free to mention that in the comments if you know more about Rust. Then the more information, the better. I'm just trying to bring to these videos what I know and what I've read in the documentation. And if there's a more complete picture, if something I say is inaccurate, feel free to mention that. So anyway, a part of any... So what I've done so far is we've gone and installed Rust, we've done Hello World. We didn't use cargo yet. I will make a video on that if the people in my Discord want that, but we made a Hello World using just the Rust language compiler. And now we're going to create some variables. So creating variables is an important part of pretty much every programming language. And so here in Rust is interesting because it's a little more complicated, I think, than some of the other standard languages like C++, Java, and Python. There's 4 ways to create variables in Rust, and there's also different types of variables too. So in this video, I'm just going to be dealing with one type of variable, and that's the scalar type of integer. There's 2 general categories. I'm just going to go over this briefly in this video. There's 2 general categories of variable in Rust. There's scalar types, which is a single value, and there is compound types, which is a bunch of values. And the scalar values are integer, floating point, boolean, and characters. So like letters, question mark. Boolean is true, false. Integer is a number with no decimals. Floating point has a decimal. And then the compound types are basically lists of those single values. So you can have a list of all one value, and that's called an array, and that's a fixed size. That's a compound type, an array. It's a fixed size. If you have 5 things in the array, then you only have 5. You can't add. And then you could have a tuple, and a tuple has multiple different data types. So you could have like an integer, a floating point, a boolean, another integer, whatever, but it's still a fixed number. So those are the different data types in Rust, and those are used to build everything. So as far as I understand, this is everything I'm explaining is my understanding up to this point. So I'm just going to be dealing with integers today, and what I'm going to be focusing on is how to create them. So there's 4 ways. There's the default way to create variables, which is called creating an immutable variable. There's creating mutable variables with a special keyword called mute. And then this immutable variable is created with a special keyword called let. And then with immutable, you have to say let mute. And then there's shadowing, which you can shadow either a mutable or an immutable, which means to make a copy of it and give it the same name. And then there's constants, which are the strictest. And you cannot shadow a constant, and you cannot change a constant. And they last for the whole scope of wherever they're declared. So first thing we're going to do is just create the most basic type of variable, which is immutable default variable integer. Okay, so I'll say let x equal 1. Okay, now automatically the compiler is saying what type of... There's different types of integers too in terms of how much space they take up in memory. Some integers are bigger than others, so you might want like a whole lot of space. This says 32-bit, you can do it up to 128 bits in memory, or 64, but for this one, it automatically just chose either. I can specify, I can say here, when I create it, I can say 128 if I really want to. But I don't want to do that. I'm just gonna type let x equals 1, and it automatically does that. Okay. And then I'm just gonna copy and paste this because I'm gonna use this a lot right here. And then I'm gonna print that variable out. So you didn't need those two things below were comments. I'll explain those in a second. So here in Rust, the way you print stuff is you say print line exclamation mark, and they call that a macro in Rust. That little exclamation mark, and it's a function. Usually, it looks like a function because it has these little parentheses, like the main function, but it has a exclamation, so it's actually a macro. And so we're going to print this out. We're going to say x is equal to the placeholder, and then put the x in that placeholder. So, and you can put the x inside there and delete it from outside and not use a comma, or put it outside, use a comma. Anyway, so what this should do is say print out, this is the program where we practice variables, creating variables, and it should say x is equal to 1. So I'm going to save it and run it. This is the program where we practice creating variables, x is equal to 1. So this is a basic, the most basic way to create a variable using the let keyword. You have to use the let keyword. You can't, if you don't use it when you're creating a variable for the first time, you'll get an error. Rust is really nice because the errors that you get are very articulate, and they explain very accurately or very clearly, I think, in regular words, which is the key for most people that don't understand something. They need it explained in regular words, not very technical programming jargon that they're just trying to learn. It explains it in regular words what that error is. So we'll probably get into some errors because I'll probably mistype something, and then you'll see. But anyway, there you go. So the next, but what if you want to change what that variable equals? So let's say in most other languages, C++, Java, Python, you can change it. You can say x equals 2, and then print it out again. What's going to happen though? Save it, clear the output, run it. You got an error. I got an error. Cannot assign twice to an immutable variable. So that means this is immutable when you create them by default. When you create a variable in the most basic way, you can't just change it. What you cannot assign that to it twice. What you have to do is you have to use, if you want to literally change the value of this variable in memory, not create a copy, not create another variable with the same name. In other words, if you want to actually change the value of this variable in memory, you have to type this. You have to say let mute x equals 2. I'm sorry. My mistake. I messed up there. You have to say mute from the beginning. So I'm not going to change the value of this x because I've already declared this variable already exists. So I can't change the value. So I'm going to declare a second one. I'm going to say let mute y equals 2. Let mute y. Let mute y. And then I'm going to say y equals all this stuff. Just for a little change, I'm going to put that in there. You don't have to. It doesn't matter. You could do it either way. And then I'm going to say y equals 3. I'm going to print that out also, just to go and have some fun, do some fun stuff. So there. Now what should print out when I run this program, if I didn't mistype anything, is this is the program where we practice variables. Then x is equal to 1, y is equal to 2, y is equal to 3. Now remember, we got an error when we tried to do this after the let, but now we're declaring let mute. We're declaring y, the variable y, with a let mute. So we should be able to change the value of y. And there it is. This is the program where we create variables. X is equal to 1, y is equal to 2, y is equal to 3. So that's how you change the value of a variable. You have to declare it in the first place as mutable. If you didn't do that, you can't change the value of it. Now, as far as I understand in Rust, this is what the documentation says. Now what we can do is the third method of creating variables. Oh, I was going to explain comments real quick. So comments are a way that programmers can describe what they're doing in regular words, and it doesn't affect the code. So all this code is running, right? So if you just start typing like regular words like hello everyone, that's giving me all sorts of errors here, because that's like not a command or coding. That's just me typing in English. But if you want to just type in English and describe some stuff and just remind yourself of stuff, or maybe other programmers add it to your documentation in GitHub or something, then, or your program, then they might have a comment there. And you can do line comments or block comments, where you say that, and then you say something on multiple lines, and that's a block comment, where you have a forward slash and a little asterisk. And that's a way also of isolating bugs. You can, there's a lot of little techniques to finding bugs, and one of them is to just comment out big chunks of your code, and then when you get an error and there's only one line of code that's running, you know that's what's causing the error, probably. So yeah, because everything in here is not affecting how the program runs at all. So if you've commented something out, it's literally not affecting your program. Okay, so it's not treated as code, it's just treated as something that the programmer reads to themselves. Alright, so anyway, we did immutable default, we did mutable. Now we're going to do shadowing. Shadowing is not actually, it's not actually, I'm going to label this mutables and immutables. Immutable, one. So here, shadowing is not actually changing the value of an existing variable. What you're doing with shadowing is you're creating a copy of something with the same name. And the old thing that had that name, as far as I understand, when I looked it up on Stack Overflow, they were saying that it still exists in memory, but you just can't access it anymore, which is bad. That's bad programming, because that means that is a memory leak, and you are wasting memory. And if you have a loop that runs thousands and thousands of times, and you're wasting memory every time that loop runs, well, then you might crash the whole system. So you don't want that. That's bad times. So don't do that. You want to be efficient, and you want to use the memory you've already allocated for a variable, and that's what mutable does. But let's say for some reason you do need to make a copy of a variable. Well, then you want to make sure you do it in a separate scope. And here's what I mean by that. So if I create if I shadow a variable, let's say I just shadow the first one I created. I shadow that x. The way I would do that is I would just say let x equal 50. Now if I print out x again, guess what it's going to say? It's going to say 50. But I have this is now basically non-accessible. It's still it's still somewhere in memory, but I can't access it, and it's a wasted memory. It's inefficient because it's basically the section memory that's blocked off, and I can't even get to it anymore. So it's better to use mutable if you're going to do it in the same scope. But here, we'll run it. I'm just going to save it, clear the output, run it. So it does compile, but it's really bad practice. So what I want to do is if I shadow something, I want to make sure it's in its own scope. And so that can be done with various control statements, like if statements or for loops. Those have their own scope. A for loop, when you create one, whatever happens inside that for loop is inside the scope of that for loop. A function, this main function has a scope right here, and that's what I'm talking about when I say in this scope. It's the scope of this main function. Scopes are defined by curly braces. So we're going to make some cool thing in Rust is you can actually kind of make an artificial scope without any control statements, which is kind of, as far as I know, kind of unique. I don't know if you can do that in C++ or Java. I don't think you can. I haven't seen it, at least. I definitely haven't seen it in Python. Maybe you can, I just don't know about it. But here it is. So I just made a scope for that. So what's going to happen is that you're still going to get this same exact output. But the difference is, if I print it out again, if I printed this out twice without this scope, it would just say x is equal to 50 two times, because it's still 50, nothing changed. But now that I've made this scope, what happens is when you create a shadow in a scope, when you create any variable in a scope, when that scope ends, that variable is destroyed. And that's true in all those languages I mentioned. So it's out of scope, especially if you try to reference it again. So now what I'm going to do is I'm going to say, so now I'm going to run it, and what it should say is all this same stuff, but after this last line, x is equal to 50, it should go back to what x was, which is 1. So it should say x is equal to 50, then x is equal to 1, because of this last line here. This x is equal to 50 now gets destroyed, and we go back to what x originally was in this original scope, defined by these outer curly braces. So run that. Okay, I don't like all this output. Run it again. There it is, x equal to 1. So that's shadowing. Shadowing is creating a second copy in memory of a variable with the same name. And you can do that for an immutable, which is what we just did, but you can also do that for a mutable. And I'll do that right here. We can do it for y. We can say let y equal to 50. Okay, find x. To 100. And then we'll say y. Sorry for the cough. Okay, so here. So now we're going to shadow the mutable. And same thing, it's just going to create a new version of that. The cool thing about shadowing is so one of the limits of mutating or creating a mutable variable, I guess, is that you can only change the value of that variable. You can't change the data type. You can't change it from an integer to a character. But when you shadow something, you can. So we're going to change this actually to the word was up. And it needs, and string literals in Rust need double quotes. If it's just a single letter, you can use single quotes. Yeah. So now what it should say is x is, this is the program we do variables. X is equal to 1, y is equal to 2, y is equal to 3, which is right here. Then we get to here, and it should say x is equal to 50 because we shadowed it, and then we shadowed this one, and we're going to say it should say y is equal to was up, and then it should say x is equal to 1. So right after x equal to 50, right after this, but before this, it should say y is equal to was up, and then it should say x is equal to 1. After x is equal to 1, it should say y is equal to 2 again. So hopefully that works. Oh, too much output. There it is, x equal to 50, y is equal to was up, x equal to 1, y is equal to 3. I said equal to 3. Oh yeah, my bad. Y is equal to 3, because that's what I mutated it to. It's what I changed it to. I don't know if that's what they say, mutated, but it sounds cool. So yeah, that's that. Now the last thing, so this is mutable 1. That's the first way. That's the second way. Shadowing is the third way. And then there's a fourth way to create variables, and that's creating constants. Constants are the most strict. You can't shadow them, and you can't mutate them. They are what they are forever and ever always. So let's create a constant. The way you do that is you don't use the let keyword, you use the const keyword. And then everything, the name of it has to be capitals. So you could name all these variables whatever you want. They don't have to be x, y. They could be just like var name or JSON variable or whatever. But here we're going to do const. We're going to just say capital Z. And with constants, you also have to declare really specifically what type of variable it is. So here I'm going to say I'll say well, 8. Maybe I only have to use 8 bits of memory for this one because I'm going to store a really small number. 8 bits of memory should store up to, oh, I should know this, 2 to the let's see, 1 bit is 2 to the 0, right? 0 or 1. And then, so 2 to the 7th. So 8 bits is 2 to the 7th. Whatever that number is, that's the highest integer in an unsigned, the highest unsigned integer it can hold. If you have signed, and then it would be half of that because you have to hold the negatives too. So I don't know what 2 to the 7th is, but let's find out actually. 2, let's see if there's an exponent. Oh wait, what? Did I not do that right? 2 to the 7th. 128, yeah, okay, so 128. So 120, it should hold 128. Is it going to hold 128? Okay, 0, 1 is 2 to the 7th. It should hold that. It should hold 128. It's either 128 or 127. 128. And then we're going to print it out. We're going to say z is equal to, I might have done some math wrong and it might be 127. Even though that says 128, I think it's like 1 less or something. I don't know, I can't think right now. But, so I'm going to save it, clear the output, run it. Oh yeah, okay, overflowing literal. That's kind of a cool error to see, honestly, when you're learning, because it's telling me here the literal 120 does not fit into the I8 type. Yeah, because so it's telling me here it'll fit. This is signed, so I8 is signed. Yeah, it is. So that's what I typed. If I did unsigned, I would do U8. Okay, and it goes from negative 128 to positive 127. That's because it includes 0. 0 is considered a positive number. So there's 128 possible values for a number. And it goes from negative 1 to negative 128, that's 128, but it goes from 0 to 127 on the other side of it. So I'm going to have to put 1. So that's why it gave me an overflow, because I tried to store a number that's bigger than is held in the bits of memory when you turn that number into binary. Yeah, that requires more than 8 bits. Because that first bit is actually, if it's 8 bits, that first bit is the sign bit, if you're doing signed. So it's actually 7. So that's why, so it was 2 to the 7th. Yeah, but it includes a 0. So anyway, this should work. Let's clear that, actually, save it. It's kind of a cool little computer science lesson there, actually. I think my computer science professors would have been happy about that explanation, kind of. All right, so there it is. Yep. Z is equal to 127, and if we try and shadow this or mutate it, it will give an error. I don't want to do that, but you can try it out yourself, and you'll definitely get an error. I've done it before, just to test it. And so anyway, that's all I wanted to go over this time. I'm going to skip all the data types. I don't think I'm going to create arrays and tuples and stuff. If you want to see how to do that stuff, maybe I'll make a short lesson on creating those different things, and maybe I'll do it with cargo so I can knock both those out in one video. But that's it. All right. Thanks a lot.